everyone. We will talk about most important topic of the NLP, which is called as a tokenization. Tokenization is nothing but converting the given text, whether it is a sentence or a paragraph, to a words and subwords is called tokens, right? So we will go in deep dive into the tokenization now. So tokenization, right? So tokenization is converting text to words or subwords. Usually we call as a tokens. We call as a tokens. So why there is a need of tokenization? The tokenization helps in building the kind of tokens from the given text, which can be used for classifying whether it is a sentiment or summarizing them or making more advanced applications after you convert, because we understand the different relationship between the words, hence we can understand the meanings, right? So hence it is very mandatory step before we proceed to the applications. So example, let's say I have an example of I love eating pizza. Okay, so this will be converted to I love eating and pizza. So we converted them to each one converted to a tokens. So next sentence, if you have, she runs in the park. If I convert, she runs in the park. Let's say we apply the before tokenization, we usually go for noise cleaning or normalization, and these whatever we have learned so far, we apply before the tokenization, right? So which could be removing the punctuations, removing the stop words, or removing the numbers, removing the punctuations, lemmatization, stemming. All this we will already apply before our tokenization, because tokenization is the last step after we clean the data. So now if we understand, let's say usually the sentences, I would call sentences or text basically, will be feeding to cleaning process or a processing or a pre-processing we call, and then we will perform a tokenization. Tokenization. That's the usual process. Let's say, what are the typical example? Let's say this is the sentence. Let's say I love 3 cats but only 2 dogs. Example. There is an example like this. Now this will be after you clean the text, which is removing the numbers, removing the sentences, removing the stop words, and converting the stemming or lemmatization, and then applying the tokenization. Then last words it will become is cats, which is cat and dog. Only these two will be retained after, because love was also there. There is a love. Right? So, which means that I is a stop word, removing the numbers will cat up, and then cats is after convert to the stemming or lemmatization, which will become cat, but is again a stop word, only is a stop word, 2 is a stop word, dogs is, remove the numbers, dogs will become a dog. So love, cat and dog, these three will retain at the last. Similarly, if I go to another sentence, she loves playing the piano. Right? So she loves playing the piano. If I convert them, love again, play, piano. So this will become, so she is again a stop word, loves will become love, playing will become play, the will be a stop word which is removed, and piano will become piano. So these three will come after you perform the cleaning, and then we perform tokenization. And similarly, if I give you a third example, I am running late for the party. If I take this, then it becomes run late party. I is a stop word, am is a stop word, running will become run, late, for is a stop word, the is a stop word, party will become party. So hence you will get a very few words. If you don't clean or stemming, if you don't perform, then it becomes a lengthy, every sentence will become a lengthy of words. So when you process many documents, many documents like this, we have a lot of documents like this, right? If you process them, every word, then the unique words, if you take, it will become a many words. Then it becomes, when you convert them to a vector space, it will become a huge matrix. And storing this matrix will take a larger RAM. So hence you need to reduce these words before you converting them to a numeric form or a number form. So this is a very critical step, text pre-processing and then tokenization. So next, after we perform the tokenization, we will convert them to a number form which can be used for a further applications. Whether it is a sentiment analysis, or whether any classification that you build, or whether you build any summarization, or whether you build any translators. That is why this becomes a very powerful when it comes to our text pre-processing, text processing basically. So we will walk through the next chapter. We will learn about after you apply, or after you get, like, let's say after you break down the tokens, then we convert them to a numbers form, which is used by the computers to understand them. So one such form is document term matrix, or a term document matrix we call. Every sentence we assume that is a document. Every token we will assume that there is a term. Term means tokens. So which is, the rows will become as sentences and the columns will become a words, which are the terms. Then the values will become whether this term or the token appeared in this particular sentence or not. Then it becomes a document terms matrix, document term matrix, which is we represent them. So that's what we will learn in the next chapter. Thank you so much.